All right, so let's talk about dividing complex numbers. This is a fairly interesting idea because there's this concept that you've already learned called rationalizing the denominator. And the idea is to make the denominator into like a whole number, a normal looking thing that you can divide by. That makes a little bit of sense because you probably learned fractions as like what you have versus how many people you're dividing it into. So if you had, let's say, 10 slices of pizza and you're dividing it among 5 people, 10 divided by 5 would mean that each person is getting 2 slices of pizza. And that's a really logical way to divide something. But there's no such thing as dividing 7 slices of pizza among 3 imaginary people. Like, that's not real. That's not even possible to think about. And even though rewriting it in some other way, it's still going to be an imaginary quantity, at least we can conceive of what the dividing by component means if we can get that I out of the denominator. And so what that looks like is pretty simple. We're going to take this 7 over 3i, we're going to multiply it by a factor of 1. That way the value doesn't change. But in particular, we're going to pick a factor of 1 that will help this denominator turn real again. And so multiplying it by I over I, that's just multiplying it by 1. The value is not going to change, but we're going to see something cool here. The numerator will become 7 times I, but the denominator will become 3i squared. And if you remember from our last video, I squared is just 3 times negative 1, which means that we can rewrite this as 7i over negative 3, or, more appropriately, if you remember, multiply that by a negative 1 over a negative 1, and we'll get negative 7i over 3. And there, even though I don't have a conception of what negative 7 imaginary slices of pizza are, at least I can conceive of dividing something, whatever this is, 3 different ways. With a complex number like this, it becomes even more complicated, but it's actually quite cool. So I'm going to do something that seems crazy, but just roll with me on it. For here, I'm going to multiply this entire fraction by a factor of 1, just like I did here, but a much crazier version of a factor of 1. And my particular factor of 1 is going to be based on this denominator. It's called the conjugate. And you've seen this before. So this was 3 plus 4i. I'm just doing 3 minus 4i. I'm changing the sign between that second term. So the 3 is positive both times, but it's like 3 plus something, 3 minus something. And then to make it a factor of 1, the numerator has to match the denominator. So now I'm multiplying by something, and the value isn't going to change. Then I'm going to have to do some coiling. So 1 times 3 is 3. 1 times negative 4i becomes negative 4i. 2i times 3 becomes positive 6i. And 2i times negative 4 becomes negative 8i squared. And then in the denominator, 3 plus 4i times 3 minus 4i. 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. And 4i times negative 4i is negative 16i squared. Now, this is where it became very cool, because look at this. These two I terms are exact opposites of one another, which means the positive 12i and the negative 12i are going to mutually annihilate one another. So, this fraction can be rewritten as, let's see, 3 minus 4 plus 6, well that's going to be the same as plus 2i, and then minus 8, but I squared is negative 1. So negative 8 times negative 1, we'll fix that in the next step. And then this becomes 9. These two annihilated one another, came to 0, so it's 9 minus 16. I squared again is negative 1. Then, I'm going to start simplifying even further. 3 times, 3, blah, 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 blah. Focus! All right, 3 plus 2i plus 8 over 9 plus 16 means that this is going to become 3 plus 8 is no, not 13. Don't be foolish, Joe. 12 plus 2i all over 9 plus 16 is 25. And that is how you turn this ridiculously complicated denominator into a straightforward whole number like we want.